In this video, we will learn a couple of important SAS procedures which can be used while dealing with datasets. These SAS Procs will be very useful while building a statistical model. So it's important that we know the different features of this SAS Procs. So what are the SAS Procs that we'll be talking about? Proc sort, proc frequency, proc means, proc univariates, and proc datasets. We'll go one by one. If we want to sort the data by a variable, we use proc sort. Syntax is like this: proc sort data, then dataset name. I'm using a dataset named students. If I want to sort by ascending order, by default it actually sorts by ascending order. There is a variable name called as GRE, so I'll sort by GRE. Let me show you the dataset. Well, the dataset that I'm using here is the one we can see on the screen. It's a dataset having 4 variables: admit, GRE, GPA, and rank. So this is a dataset on student admission. Okay, so proc sort data, dataset name by GRE. Okay, if you run this, this will sort the dataset in ascending order. Let's go and see. You can see the dataset is sorted in the ascending order, right? 360 being the lowest GRE and 800 being the highest GRE. Now, what if we want to sort it by descending? So after the by statement, put descending. Go and see. You can see that the dataset is sorted in the descending order, starting from 800 and the last one is 360, the lowest one. If we want to save the sorted data in a different dataset, an entirely different dataset, we can use the out statement, out equal to, and then give any name. Okay, student 2. Okay, so that's my dataset. I want to sort this dataset, the parent data, and put it in the out data. If this data or the parent data is not sorted and you are sorting it and using the out statement, your parent data will not be sorted. Only the out data will be sorted. Okay, so you're creating a new data by sorting the parent data. So that's the use of out statement. The parent data will remain as it is. What if you want to sort it by 2 variables? You want, say for example, there are 2 variables, GRE and GPA, right? I want to sort the data in the ascending order of GPA and the descending order of GRE. So it's a two-way sorting. How do I do that? Look at the syntax. By GPA, descending GRE. So by default, it will sort it in the ascending order of GPA, and then it will sort it in the descending order of GRE. So let us change it. Okay, GRE, and let's make it GPA. The reason I'm changing it is because GPA is a continuous variable, so it will be very difficult to actually figure it out whether it has sorted properly or not. So for convenience purpose, I'm just changing the variable names. Okay, let's go to the log. It says that it's sorted properly, and then let us see our data set is student 2, right? Yes. Okay, look at the data set very carefully. You can see that our data set is sorted in the ascending order of GRE because we have mentioned GRE as the first variable in the code. So by default it sorts the data set in the ascending order. Now look at the cases where we have repeated GRE value. For example, last value, like how many students have scored GRE of 800. There are 4 students who have scored GRE value of 800. Now look at their GPA values, right? You can see the GPA values within the 800 GRE category as sorted in the descending order. 4 being the highest goes down to 3.75 and then 3.66. Similarly, there are a couple of students who have scored a GRE value of 700. 3 students, right? Look at their GPA value. It's sorted in the descending order. 4, 3.9, 3.0. So the descending order is within a particular GRE value. For a particular GRE value, if it is repeated, the corresponding GPA value of the students is sorted in the descending order. So that's the the double sorting or sorting by 2 variables. The next procedure that we learn is proc frequency. If we have a categorical variable, we use proc frequency to get the proc frequency count of the variable. Okay. We'll use the same dataset students, then table. So for which variable we want the frequency. In this case, we have a variable, categorical variable named as rank. Look at the SAS output of proc frequency. We have the number of counts, the percentage, individual percentage. Okay, if you add them up, it will be 100. The cumulative frequency and the cumulative percentage. That's all you get in the proc frequency. We can have 2 by 2 cross tabulation or even 3 by 3 cross tabulation by using the proc frequency. We don't have 2 categorical variables in our data set, so let us create another categorical variable. I'll create students 1 set student if GRE is greater than 500, indicator is equal to 1, else indicator equal to 0. So I'm doing is I'm creating a new indicator variable based on the GRE value. Okay, so if the GRE value is greater than 500, it's 1, else it's 0. Why am I doing this? Because I have only one categorical variable in my data set. I wanted to create another one so that I can create a 2 by 2 frequency matrix. Okay. Now let me run this. I'm assuming it is created. Let me check the log. Yes. So I'll be using the students 1 dataset instead of students. So if you want to have 2 by 2 cross matrix, just put asterisk and then put your indicator, the second categorical variable. Well, you can see you have rank in the rows and indicator in the columns, and their corresponding cross tabulation value. How do we interpret this output? Rank is 1, indicator value is 0. How many observations are like that? 1 observation. What is the percent? Well, there are so many other things, right? Yeah. So there are 4 values in every box, right? What are they? First one is frequency, next one is percentage, overall percentage, row percentage, and column percentage. One is the overall number of variable, observation, where rank is 1 and indicator is 0. What is the corresponding overall percentage? 3.45. What is the row percentage? Row percentage means, it's like how many observations are there in the row. So this is the row, right? 1 plus 7 plus 8. So what is the row percentage? 1 by 1 plus 7 plus 8. So 1 by 16 is nothing but the is that correct? Okay, sorry. So that's total, right? 8 is the total. I'm sorry. So it should be 1 by 8, right? 1 by 1 plus 7. So that's the row percentage. And the column percentage is 16.67. What is the column percentage? You add all the values in the column, same column. 1, then 1, and then 4. So there are 6 observations in the column. So 1 by 6, that's nothing but 16.67%. Okay. Similarly, we interpret the other boxes. So rank 1, indicator 1, total number of observation is 7. The overall percentage is 24. Row percentage is 87%, and then column percentage is 30%. You have your corresponding row and column percentage, and this particular box will give you the total number of observation and the cumulative the percentage there. The next proc that we will okay, before going to the next proc, we can always use a third variable also. We can have 3 by 3 cross tabulation matrix in proc frequency. The next proc that we'll be learning is the proc means. Well, proc means is statistical in nature. Proc means is used for computing basic statistics like mean, standard deviation, variance, the number of observation, these sort of things. Of course, you can also get to know the number of missing values. So proc means is used what is given in default: number of observation, mean, standard deviation, minimum, and maximum. So these are of statistic given by default. Of course, you can mention any particular statistic that you want, like say for example you want only the mean. You can mention in the option that I want only mean, and it will give only the mean in the output, as you can see here. You can get it for only one variable. Mention the variable name. I want it for only GRE. So use the var statement, and then that's it. If you want to know the number of missing value, you can use a very important option here, mmiss, so that you can use it to know the number of missing values in a particular variable or a group of variables. Remember, proc frequency is used for categorical variables. Okay, It's never used for continuous variables. Of course, you have so many values, so never use a proc frequency for continuous variables. And never use proc frequency, proc means for categorical variables. Proc means is used for continuous variables. It doesn't really make sense to use proc means for categorical variables. The next important proc that we'll learn is the proc univariate. Proc univariate is used to analyze a particular variable. As the word univariate means, it's a single variable analysis. There is only one variable we can analyze at one time. So if your data has 5 variables, we have to run proc univariate 5 times to actually know how our data is distributed. So what are the statistics related to that particular variable. So many things can be done using proc univariate. I have covered proc univariate in detail in the video exploratory data analysis. The important things that we can do using proc univariate is we can check for normality of the data. We can get to know the quantile distribution of the variables. Of course, whatever we get from the proc means, number of observations, your mean value, standard deviation, everything we can get even in proc univariate. Moreover, we can also graph the we can plot the observation. So all these things we can do. You can do using proc univariate. Go through the video on exploratory data analysis and you will learn more in detail. I'll just write the syntax here, students, and I'll do it only for a variable GRE. You can see everything is there: number of observation, mean, standard deviation, skewness, coefficient of variation, and then median, mode, range, interquartile range. Everything is there. Everything related to the variable. You have hypothesis testing for the mean, and then quantile distribution. As you can see, from the 100th quantile to the 0th quantile, percentile, and there are quantiles as well, Q3, median, and Q1. You can also get to know the outliers in the form of extreme observation. So the lowest number of observation and the highest observations in your data set are they are in the extreme observation table. So you can detect the outliers also using proc univariate. Outliers or the extreme observation that are different from the normal observations. The last one is the proc dataset. Well, the proc dataset is used to know what are datasets in our library, in a particular library. Okay, it is very important because sometimes one of the library has too many observations. When you do this sort of an analysis, you will have just too many datasets, unnecessary datasets. Okay, so in between steps, between different data steps, some dataset you may not need in the later steps, and you may want to delete the dataset. It's important to know what are the data sets are there in my library. So if I want to know I want to know what all data sets are there in the work library. Proc dataset library, and then keyword library name. Okay, so what I have missed is the S. It should be data sets. Go to the output. Well, nothing is written. Maybe I need to put the quit statement. Okay. In the output, we can see the number of data sets and the details about the data set. Okay. How many data sets I have in my work library? 11 data sets. And the details, file size, and then the last modified. These details are there. Okay. How do I drop a data set? How do I drop a data set from the library using proc dataset? I write drop or delete. I forgot the syntax. It's delete. Okay, delete ABC. So the dataset ABC will be deleted from the library. Go to the log, and it's written that deleting work.abc. So the dataset ABC is now deleted. So that's the end of the session. We have seen how to use a number of procs, and we will also there are a lot of other procs also which are very important. Uh, we'll also cover a couple of more procs in the subsequent videos.